Okay, so we've come to the end of the first chapter. Now we have the first set of homework problems. So for the first problem of the homework, it's a relatively simple question. I've given you a number in some units. I ask you to change units, and you need to determine how that number changes. So let me give you an example of how I want you to think about it. So let's imagine I give you a speed of 1 meter per second, and I tell you I want you to convert that into something which is kilometers per hour. So you simply have to calculate the number that sits there, okay? And the logic that I'm going to show you here will work to convert anything. It's very simple. You've probably seen it, but let's go through it anyway. So we've got 1 meter per second. Now we're going to multiply this by 1 kilometer over 1,000 meters. Now, because a kilometer is 1,000 meters, I'm just multiplying by 1. And then we're going to multiply by 3,600 seconds divided by 1 hour. And of course, an hour is 3,600 seconds. So again, I've just multiplied by 1. Now, why is this a useful thing to do? Well, this meter will cancel with that meter. This seconds will cancel with that seconds. And I'm going to be left with something which is a kilometer per hour. That's exactly what I want. So I've got 1 times 1 times 3,600, which is 3,600, divided by 1,000, which is 3.6 kilometers per hour. So you can always change units by multiplying by a suitable one. Okay, maybe just one more to really illustrate the point. Let's say we take 1 meter cubed. It is equal to a certain number of centimeters cubed. So how do we do this? 1 meter cubed times by 100 centimeters over 1 meter. That's certainly I've multiplied by 1, but I want to divide out a meter cubed. So let me cube this. And then 100 is 10 to the power of 2. 10 to the power of 2 cubed is just 10 to the 6 centimeters cubed. Okay, so these conversions are always done by multiplying by 1. Okay, next comment is in one of the problems, I've asked you to calculate the size of certain relativistic corrections to a state of the hydrogen atom. Now, I don't expect you to remember the wave functions of the hydrogen atom, but certainly you will have a favorite textbook on quantum mechanics, and you can simply go and look up what the wave function is. So remember, the wave functions of hydrogen are labeled by principal quantum number and angular momentum, and then this quantum number m, which selects which angular momentum state we have. This you could think of as a function of in position space, or more properly, or sorry, not more properly, but maybe more conveniently, it's a function of a radius and 2 angles. So look up that wave function, use that wave function, and then you'll very easily be able to evaluate the matrix elements that I've asked you for. Okay, so I think the rest of the problem should be pretty straightforward. I don't think you'll need any other hints. So good luck with those, and let's get going with chapter number 2.